Thanks for returning to our video series. Today we're going to be focusing on home or residential soda systems. Most people are unaware that you can have a commercial quality soda system installed in your home. Most homeowners are able to install these systems themselves. So we're going to be focusing on just a couple component parts today. The syrup and syrup delivery system. We'll be looking at CO2 and CO2 equipment, carbon dioxide gas, and we'll be looking at the carbonator, which is a major component for home soda systems. And then we're going to be looking at the various types of chillers that you can use for a home soda system. And lastly, we'll be focusing on the three major dispensers, which are towers, soda guns, and draft arms. All soda systems are based on a concentrated bag-in-the-box, or BIB system. This is a 2.5 gallon bag-in-the-box. You can buy this in 5 gallon, 2.5, and 1 gallon. Essentially, a 5 gallon bag-in-the-box will give you about 30 gallons of finished product. Every brand has its own connector. In this case, I have a red Coke connector. If you had a Pepsi product, you'd have a green Pepsi connector. And then all the other ones fall under a generic connector. Essentially, you connect up the box, and then you're going to have a syrup pump for every flavor that you have. And all this syrup pump does is draws in the syrup, pumps it forward so they can go through the chiller and onto the dispenser. There's two major brands. This is the SureFlow pump, and this is the FlowJet pump. They're pretty much interchangeable. Functionally, they do the exact same thing. Syrup in, syrup out, and then a CO2 connection. All right, carbon dioxide. Basically, CO2 can be purchased by anybody. You can go to all the major gas suppliers, ARC3, Airgas, these type of companies. You don't have to have a special license or anything to pick it up. So basically, most home systems are going to either use a 20-pound tank, a 10-pound tank, or a 5-pound tank. It's more common to use a 20-pound tank. A 20-pound tank will get you about 60 gallons of product. All right, so what we have here, so your syrup pump can be mounted whatever's convenient in a cabinet or in a remote location. Same thing with the CO2 tank. It doesn't have to be necessarily close to your dispenser. You can run lines, very long lines, out to a garage or out to a back room. So what we have with the syrup delivery or the CO2 system is a CO2 tank and then a regulator. Essentially, they're connected directly to the tank. This is an empty tank, but if I was to open the tank up, I would read the pressure of the tank. In this case, it'd be like 800 or 900 pounds of pressure. And then you have one line coming out of the regulator. You can adjust the pressure so that the output of this line is 100 psi, and that's the desired pressure. And what I have is the line going out of the CO2 tank and then into the carbonator. So basically, this is delivering CO2 gas to the carbonator where your seltzer will be made. And we'll talk about that in just a minute as well. Now, on these systems, it will tee off. So you'll have your 100 psi going down to your carbonator. It'll also go to a secondary regulator. The secondary regulator can be adjusted as well, and it will be set to 55 psi. The secondary regulator is what drives your syrup pumps. So you can see it snaps in. So essentially, these are gas-operated pumps. There's no electricity required, and it just runs off of gas pressure. And what happens is, if you're all set up and you dispense a soda, you'll hear this pump a few ounces of syrup up to the valve. You'll just go pop, 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 and it'll be done. Whenever you're not dispensing soda, the carbonator and the pumps are just basically sitting idle. So these are gas-operated CO2-driven syrup pumps. Now, you can hook up multiple pumps. So basically, you would have one pump going into a T, and it would feed the next 2 or 3 pumps, and it runs in series. So you've got one input coming off of the secondary regulator running your pumps. So that's really all you have for a CO2 system. CO2 tank, primary regulator, secondary regulator, lines going down to your carbonator, and lines running your pump. It's as simple as that. Whenever you want to change a tank, you simply close down the gas, disconnect the pump, this large nut here, the regulator comes off, grab a fresh tank of CO2, put it back in, tighten it up, turn it on, and you're back up and running. So for a home user, you don't need any special techniques or anything. You can basically just swap those out yourself. Now we're going to talk about the carbonator. Basically, the carbonator is where you create your seltzer water. All soda systems have this basic system carbonator. This happens to be a McCann's carbonator. Essentially, it's an electric unit, runs on a standard wall plug. Has two inputs. The one input is going to be your house water, your water source that goes into this water pump right here. You do have to have a range of about 35 to 60 psi for it to work properly. So the water comes into here, plain water comes in, and it's pumped into this vessel. And then if you remember, we had our CO2 gas coming in. CO2 gas is at a higher pressure. The gas goes into the water and creates seltzer water. It's a very simple system. There is a float mechanism, and that turns the unit on and off. Most of the time the carbonator's off. It's sitting there waiting to be used. If you have a dispenser and you grab a couple of drinks, eventually you'll deplete the tank. It'll kick on for say 15-20 seconds, replenish itself, and be ready to go again. Pretty basic system, but it is the heart of all soda systems, is to create your seltzer water right here. So now we're going to start talking about chilling devices and chilling methods. Basically, the lowest cost method is to use a very heavy aluminum cold plate. It's a real common system. Basically, you have an aluminum block and you have stainless steel lines internal here. And the idea is you put this inside of a cooler, cover it full of ice and icy water. The aluminum block will get to be 34, 35 degrees Fahrenheit. And then you're going to run your seltzer water and your syrups through one side, through the cold plate, and then they come out of your insulated side, trying to get to a temperature about, again, 35 to 39 is a good temperature for seltzer water. The problem with a cold plate is there is maintenance involved. You have to put it inside of a cooler, you have to drain the ice away the water away as the ice melts, and you have to keep replenishing ice on it. So it's definitely not an on-demand system. You can't have soda ready 24/7. So what we've done is we've integrated a cold plate with an ice maker. So basically this same cold plate is put inside of an ice bin. This ice maker makes ice 24 hours a day, fills this bin full of ice. The ice can be used and consumed, but primarily it's chilling the cold plate. And this is an upgrade from the basic cold plate. The next thing we're going to look at is electric chillers, refrigerated chillers, and that is a step up from a cold plate system. Okay, so now we're going to talk about refrigerated chiller options. We talked about the cold plate and the limitations to a cold plate. This is a great option. These are both refrigerated units. I'm going to take the lid off of this one so you can see what's going on. Basically, this is a free-on charge refrigeration system. And again, both of these units work off of standard 115 wall circuitry. And the way these work is you fill this water bath. You can't see it, but there's a tub in here, a lined tub. You fill it full of water. You turn this unit on, and over about 3 or 4 hours, it'll make a block of ice inside of the water. There's also a circulation motor that moves the water around to keep it very cold and uniform. And basically, you take your output, your seltzer output from your carbonator, and you run it directly into your chiller. And then we talked about the pumps and the output to the pumps. Those the syrup lines run directly into the chiller. And they go through a whole series of stainless steel lines coming in at say 70 to 80 degrees. They come out at 35 degrees or so coming out of here. And that's what you're looking for to have a good cold fizzy beverage. Very low maintenance, fill it full of water, turn it on, kind of forget about it. The water is obviously very cold, evaporation rates are low. You do have to look in there periodically every few months and top it off with say a cup of water. So a great unit. A little bit big. A lot of people do use these in their home configurations. We also sell these a lot to bistros, coffee shops, small restaurants, the like. So this would be paired up with, say, a tower dispenser or maybe a soda gun dispenser. Let me take this much smaller hood off. Also electric refrigeration unit. It has a refrigeration deck under here. It has a smaller deck. This one's a pretty big size deck. This is a smaller deck, but it's a compact unit, so it does really good. It's very efficient. Basically, the water bath is on the top. You fill this full of water. Same concept. It makes a block of ice, and it runs automatically when the ice melts. It replenishes itself. I didn't mention these run till they make the ice, and then they turn themselves off, and they stay off until the ice melts, and then it turns itself on automatically and runs for another hour or so. Same thing with this one. The big benefit of this one is this carbonator goes away. Instead of having the plain water going in here and the seltzer water going in here, You send the plain water into this unit and the carbonator is integrated inside of here. So all of this is built inside of here. So you don't have to deal with the size of the carbonator. So this is a really great option. So now that we have our chilled beverage going through either our chiller device or our cold plate, those two lines, your seltzer and your syrup lines, are going to be going up to one of basically 3 dispenser heads. Very common one is called a tower. It's a freestanding unit. You put this on top of your countertop. This is the only thing you'll see. Everything else can be tucked away. And essentially these come in variation from 1 valve all the way up to 6 valve. And they can be configured with seltzer water, plain water, carbonated, non-carbonated, pretty much any combination you'd want us to hook it up as. The second most common one is a soda gun, or very common you see in restaurants. This is actually a commercial soda gun. Same thing, this is tucked away underneath your countertop, and really all you see is the soda gun. There's a couple of ways to present it. There's a soda gun holster that you can mount on the corner of a cabinet, and you can kind of holster it that way. There's what's called a waitress station. I'll just briefly show you. You can kind of position this semi-permanently where this goes under the countertop, and then you put a cup under there and dispense it. Kind of simulates a tower scenario. But the most common way to do a soda gun is to put it as a retractable situation like this, where you dispense your beverage and you just let that hide under the countertop. That does require cutting a circle or a hole inside of your countertop. The third option is what we call a draft arm. Draft arms can be mounted coming through the countertop. Again, everything else is tucked away, and this is all you see. This one's set up as a seltzer system, but we do have variations that allow us to do 1 or 2 flavors in soda as well. So those are the 3 most common dispenser heads used in a home soda system. Thanks for watching this video. We are Soda Dispenser Depot. You can find us online, sodadispenserdepot.com. We sell hundreds of systems and parts. Check us out.